1 for x, 1 plus 4 is 5.
Alright.
So you can check yourself just like any equation.
Something's not clicking here. I got like the 3x plus 1.
Yes.
Wouldn't you divide 3? Wouldn't you divide 3 to get it away from x?
What are you solving for?
Solving for y, but
Solving for y. Is y by itself?
Yes.
yeah.
Yes.
Okay.
You can't solve for y and x, because that 3 is going to be either here or it's going to be 1/3 over there. There's no way to get them both with a
So
1.
don't worry about x at all in this.
Because what is that number here?
That's the slope.
That's the slope. I need that, don't I? So we're trying to do this. Whatever ends up here is a slope, and whatever ends up here, of course, is the y-intercept. So that's why I focus all my attention on that y. Get that y alone. Get that y alone. Then I'll look on the other side. Guys, I'll look on the other side and say, oh my God, what the hell happened over there? And I can pick out the slope and the y-intercept then, right? So I don't care about anything else except getting that y by itself, and then everything falls into place.
Okay.
Okay. So that's the graphical method. And you can see, like I said, if you had equations, would you want to do this one graphically here?
Will you ever have us shade sides of the line?
Would you want to do that one graphically?
Freaky fraction.
No. Would.
Graphically, no. Right? Because you can see really quickly you're going to get these ugly slopes and these really ugly y-intercepts. And I'd have to be like really precise. Oh my God. Right? So I don't want to do that one graphically. There must be another method, right? Obviously there's got to be an algebraic method since we're in algebra class. Yes. So one method is called substitution. So I'm going to hold off on that. That's the last one we'll do today. We'll do that one at the end. Because that's like the ugliest one we'll see.
Will you ever have a shade with these?
Eventually. You only shade though when you have inequalities. So if I would have put a greater than or equal to on one of those.
Okay.
Yeah. So yes, that will come up. Alright. So algebraic methods. Substitution, very appropriately named. Both of the algebraic methods we're going to talk about try to deal with the fact that there's too many freaking letters, right? Why can't I solve this by itself? Well, there's two things I don't know.
You don't know what y
Like we
is?
just found out, we can't solve for y and x at the same time. So the substitution method is very direct in a way. It gives you a really nice way to solve it at the end, but it's at the same time it's really subtle. It just kind of replaces a letter with the other letter, right? So for example, I have something like x equals 2y minus 3. I always love that. All right. Let me make it work. All right. Okay, Jeff. Don't forget that. There you go. And let's say I have 4y minus 2x equals what, Jeff? I don't know. What do you want from me?
10.
Let's make it 4 minus 3. Sorry. Just deal with it. 13. Okay. Yeah.
Wouldn't you just go 4y minus 3 parentheses 2y minus 3 close parentheses
I
equals
love it.
13?
Now, why can we do that? Let me make sure everybody's with me on that. Lisa. So here's the thing. This first, guys. So this first thing is a piece of information that I can use. I know it's true, right? X is this. And then look at the second guy. 4y minus 3 times x is 13. But what do I know about x?
You already know that.
2y
What is it?
2y minus
I know that x is this, don't I? Hence the name substitution. You replace this with what it is. Now notice what's got to be true for substitution to work easily. I've got to have a variable that I can solve for easily, right? So on this problem here, I would not want to use substitution. Because anything I try to solve for, don't I get all these fractions? Right? And if I don't have to deal with fractions, I'm not going to. Because that's another place for me to make a mistake, right?
So, Professor,
So-
in order for me to get this straight, I'm just going to guess that
Okay.
Number 1 is what x equals, and number 2 is the equation to get what x equals.
No. That's the way I'm looking at it right now, but these are both pieces of information. I want to use them, don't I? Right?
Yes.
Substitution, you're just gonna plug it in where x is, right?
So if I had like, I'm trying to figure out the murder, and I'm like, oh, this guy's a suspect, but he's allergic to peanuts. I know that.
Great.
And I know that the guy was murdered in a big vat of peanuts. Let me put those pieces of information together, and I think that probably this guy didn't do it, because he would have died jumping into a vat of peanuts to kill somebody. I mean, that's a silly example, but I used one piece of information in another one. Right? That's exactly what we're doing. We're using this. Why did I do it the other way? Because this is solved for x already.
Right.
So I can take this piece of information and use it inside this one.
You just got to find what 2y minus 3
I'm
equals.
just not meant to have more than one color.
Oh, okay. I get it now.
Alright, here we go. So now I got 4y minus 3.
Times
Times
2y
2y
minus 3.
equals 13.
How the hell do you get that?
Distribute.
Oh my
Just
God.
plugged in the,
Can't use that one either. It's going to make me high. It's really. Alright.
Now order of operations.
Oh, you plug in the first
I'll use it
one.
later. Right.
Okay, I see.
4y minus 3
Because that's
times
what x
x.
equals.
But x is this.
Right.
Right.
Cool. And now, this is what I meant by it's subtle. It eliminated a variable by replacing it. It's like the body snatchers, right? So 4y minus...
Wow.
Plus 9.
And can I solve... Now I can solve this for y.
easy.
Yeah.
Instead of 2 variables, I have 1.
Right.
So negative 2y, I can subtract the 9.
Right.
Now I'm curious to see if I made this work. Yay. And then divide. So you go y is... Now, are you done? Why? Because you know its answer... An answer to a system of equations is a point. So you gotta have an x piece and a y piece. I got the y piece.
You gotta plug the white piece.
Well, into that one. Yeah.
And I'm gonna pick, I can do either one, but why the hell would I do that when that's already solved for
Because you
x?
gotta find what x's.
So now if I take this and use it there, x equals twice y, but y is
Negative
negative 2.
minus 3.
Minus
So
3.
it's
So the x
negative
is
7.
Negative 4 minus 3, yeah. X equals negative 7.
Cool.
Negative 7?
How you guys doing?
Okay.
Now you see why I had to keep track of what I was. Yeah, anyway.
You are still in.
That's not too bad there, right? Now, are they all going to start off looking like that? No, they're going to start off looking like this. I like that quick.
Are we still in 4-1?
Oh, yes.
Yeah.
So you have your 2 points you can find on the graph, right? Which would be negative 7, negative 2, right?
If you were to graph these lines, they would meet at the point.
Negative 7, negative 2.
I love it. Right. In fact, if you leave it like this, it's okay, but really, this would just make a math person's heart skip a beat. Because that's the answer, that point. If you leave it like this, as long as I can find your answer, I'm happy. But make it a point, you oops here.
And where you don't go any farther after that, you've solved the equation, you're done.
Yeah, you're done.
Okay.
Now you can check yourself by plugging it back in, right? So if you plugged in, well, you can check yourself by plugging it back in. Right. All right.
Just go in reverse, basically.
So here, you guys,
Okay.
what would I do with this here? Here we go again.
Oh boy.
You would substitute, you would take the,
Wait, let me get it up here first. Sorry.
You're allowed to move things around.
You can do
Just substitute.
anything to each of them that you can do to any equation because they're
You have
each
two
equations, right? These are each equations. I wrote it down like this. Did I have to write it down like that? If you added the x, isn't it the same equation? If you add x to both sides,
You get
is it
4y.
not the same equation? Yes. It just looks different, doesn't it? Yeah.
you would actually multiply and switch the, I would probably do the first one, put the multiply by 3 on the first one.
No, be careful. You're getting ahead of me again. I want to focus on
So it ends
substitution
up
right
like
now.
this.
Oh, okay.
You're doing my favorite method, which is elimination. That's coming up
Like
next.
this.
So I want to do substitution. In fact, the instructions say you must use substitution.
Okay, so
I don't know,
when you
throw it
so
down.
when you
So isolate the x. On the
Because
first
X
one?
by itself is nothing there
That's
now.
just the thing.
Which variable is the best? Why do you say X is the best to solve?
Because you
Because
can
it
add it
has
to
a
both.
number, right?
It's got no number in
You
front
can
of it.
add it to both sides too.
Over here, this is nice. It had a 1, it's already solved. Jeff. It had a 1 in front of it already. It was by itself.
Right.
But here, nothing's by itself. But the X is the easiest thing to get by itself.
You can
So I
add.
do work with this one a little bit. What could I do?
You can add add X to both sides,
Add X to both sides, I like that.
Uh-huh.
and then it'd be 2.
Subtract 2, right?
Right.
Yeah.
So I get X is
4y
minus
minus 2.
2.
And notice something real quick. Notice how I keep numbering my equations so I remember which one came from where.
Heck yeah.
The biggest problem students have with this is, especially the messy students, and I am myself a messy student, so I've learned over time that I have to do this bookkeeping.
What the hell are you doing to each other?
You must keep your books, right? This number one equation, I know where it came from. Where do I want to plug it? Do I want to plug that back into here?
No.
No.
I never plug an equation back into itself. I'll always get 0 equals 0. Of course it's always true if you plug it back into itself,
How
right?
do you get this? Oh.
Are you guys with me? You've got to use both pieces of information. Here's a piece of information number 1. Where do I want to plug this?
You plug it into
Into
the second
number 2.
equation. So you have 3 times 4y minus 2
Yeah, so
plus
3 times x, but what's x?
4y minus 2
4y minus 2.
plus 5y equals whatever.
Yeah.
Another big mistake is people forget to write that plus 5y. You feel like you wrote enough. But you know, if you forget to write that plus 5y, you're going to get funky answers. You got to be 3 times x. X plus 5y equals 11. Right? It's the same equation. I've just replaced x with what I know it is.
Right.
And what-
So on the number 1, you're not dividing 2, you're subtracting 2,
Yes.
so 4y minus 2, you're not trying to divide.
Yeah, I can't divide this. I got to cancel the addition, so I've got to subtract.
You could have very well moved the 4y over and then multiplied by -1.
Exactly. It would have gotten the same place.
Right.
All right. And now what can I do?
You
Distribute.
Add the 6. 12 and 5 is 17. Y equals 17.
y equals 1.
Y is 1.
And 2x.
And then now I still need x, right?
Plug it into the first equation.
So x equals 4 times y. Y is 1.
X just equals 2.
So x is 2.
And we're done.
So the point is
2, 1.
2, 1.
That's the point where the lines
That would be
cross.
the point where these two lines would meet, 11. Right?
First equation.
Sweet.
Okay. Yeah.
We're, okay.
Let's just
Your y equals 1, that's, okay.
From this,
Okay, and then where did you plug that?
You plug the 1 back into the,
y equals 1
there, yeah.
1 goes back
into
to
the other
x.
one. Right?
So that's not the
I know
first,
y
that's
is
not the
1.
first equation though,
You
that's,
could have put it in one of the top ones, correct?
Once I get one letter, how do I get the other letter? I can use either one of these. Right?
Plug your answer
Well, what's
back.
the easiest equation
The
to
one that
use?
says x already.
Yeah, so now watch. I want you guys to see this. We got the answer. It's done, right?
Right.
It's done. But just to show you, I know y is 1. Let's plug it into number 2.
all right.
3x plus 5 times y, which is 1, is supposed to be 11. Subtract the 5, 3x equals 6, x equals
2.
2. I get a 2 anyway?
You get the
Of
same one.
course.
So you check yourself, it comes out the same.
Of course I do, because it's the point where they both meet. So I don't care which one I plug that y back into, they're both going to be the same damn output because that's where they both meet. That's where they both are, right? So I'm going to use the easiest equation. But it doesn't matter really which one you use. It doesn't.
So you just really gotta pay attention to your problems, you know.
I know. Keep track of which one is which.
Yeah.
Number them and keep track of them. Trust me.
So you're going to get the same answer in both equations if you check yourself.
Yes. All right, so let's talk about elimination method. That's my personal favorite.
Kill that.
Only
Kill
a math
that.
teacher would have a favorite
Faster.
algebraic method of
Jeff, you
solving
like-
system equations.
You have to be like, kill that integer.
Yeah, exactly. It's very direct. Elimination. Eliminate them. So start off nice. Let's see, what do you want, John? I don't know.